So January 2017 paper 4, unit 4 basically. You can also state the answer if you know, like you understand the question, you can directly say the answer. So I'll move on to the next part. So the rate of the reaction of the rate equation for the reaction in which carbon disulfide decomposes is shown. What is the unit for a unit of rate constant K? So K will be rate divided by the concentration of CS2. What is the unit of the rate? Unit of rate is mole per dm cube second. And what about the unit of concentration? Unit of concentration is mole per dm cube. So this mole per dm cube cancel with mole per dm cube, so it will come out 1 over second, or we simplify, so this will be second inverse, so B will be the right answer. Then the chemical equation and the rate equation for reaction between nitrogen monoxide and bromine is shown. When the concentration of a nitrogen monoxide is half and the concentration of bromine is double. Look, we will check the order. This is first order with respect to bromine and second order with respect to NO. So what happened when the concentration of nitrogen monoxide is half? So if this is divided by 2, this will be divided by 4 because it's a second order. So second order, if the concentration is double, rate will be 4 times. If concentration is half, rate will decrease by 4. So because of this, the rate is decreased by 4. And the rate is first order with respect to bromine. So the concentration of bromine is double. So if this concentration is double, first order rate will also be double. So rate is multiplied by 2. When we simplify, it will be rate divided by 2. So that means that the overall rate will become half of its original value. Any question you want me to repeat, you just let me know, so I will repeat that. Or you're not able to understand, you can also let me know. Any question or a part. In question 3, the graph shows how the rate constant of a reaction K changes with the temperature. So what is the relation between the rate constant and the temperature? They are not directly proportional. If you increase the temperature, rate constant also increase, but not directly proportional. So two reactions, A or C, in both cases, when we increase temperature, rate is increasing. But A means they are proportional to each other. They are not proportional to each other. So that's why C is the right answer. If they were directly proportional, like if double the temperature, rate will be double, K will be double. So in that case, exactly double. In that case, we call a linear and a direct proportion relation, so it will be a straight line. Is it clear, this question? In question 4, when solid sodium hydrogen carbonate is added to dilute hydrochloric acid, mixture start to fizz and the temperature drops. Which statement about this reaction is not true? Temperature decrease, it means the reaction is endothermic. And endothermic reaction, the total entropy, for every reaction, total entropy is the system plus surrounding. And what is the entropy change of a surrounding? That is minus delta H by T. So entropy change of a surrounding will be negative. So which statement about this reaction is not true? Delta H is positive. Delta H, because temperature drops, so it means that total and the reaction is endothermic, and endothermic reaction delta H is positive. That's true. Entropy of a surrounding will be positive. It cannot be positive because Delta H is positive and negative sign is for formula. So overall entropy of a surrounding will be negative. So that's why B is the right answer. Entropy of a system increases. Why? How we identify? Because solid and aqueous, and here aqueous, gas and liquid, and more particles are there. And total entropy is positive. Reaction occur. If the reaction occur, it means the total entropy should be positive. There is a decrease in entropy of a system. When so entropy is decreasing, it means the particles should come close to each other. Yeah, that's right. So C will be the right answer. The vapors are condensing. Then question 6, what is the enthalpy change of dissolving a sodium chloride in water? So entropy change of a solution or enthalpy change of a solution is hydration minus lattice or minus lattice plus hydration. It's the same thing. So whenever, because what happened when we draw the Born-Haber cycle, like first we have a sodium atom and we have a chlorine molecule. We convert them into an ion, sodium ion and chloride ion, and they combine to form sodium chloride. So first these sodium ions and chloride ions turn into sodium chloride. That is called a lattice energy. Enthalpy of a solution means when the element dissolve. That's called enthalpy of solution. And hydration energy means when ions in the gaseous state, because here ions in the gaseous state turn into ions in aqueous state, we call hydration. So we can draw Born-Haber cycle, or we can also use this concept. Like example, we have say sodium ion and we have chloride ion, and it forms sodium chloride NaCl. So we call this as a lattice energy. Or first sodium ion in a gaseous state, chloride ion in a gaseous state form sodium chloride, like sodium ion in aqueous state dissolve, and chloride ion in aqueous state. So we call that as a hydration energy. And or the sodium chloride, which is solid, dissolve and form sodium ion in aqueous. So that is called enthalpy of solution. So when we use a Born-Haber cycle, so start of the cycle where two arrows are pointing out, end of the cycle where two arrows are pointing in. So we can write that lattice energy plus the enthalpy of the solution equal to hydration energy, or lattice energy is equals to hydration minus enthalpy of solution. So hydration minus enthalpy of a solution, or or if we need enthalpy of the solution delta H, that will be hydration minus lattice energy. So hydration energy minus lattice, or minus lattice plus hydration. So which one it matches with, in which the lattice energy is negative and hydration energy. So it matches with option D. So D is the right answer for this. Is it clear? Question 7. Energy is given out when 1 mole of a gaseous sodium ion is hydrated, like sodium ion in a gaseous state surrounded by water molecule. So this reaction is more exothermic than corresponding potassium. What is the hydration energy? Depend on two things: size of the ion, positive ion should be small as possible, and the charge on the ion should be large as possible. That will affect the hydration energy. So why hydration of a sodium is more than potassium? Because sodium is having a smaller radii, so it will form a strong bond as it is a result of strong bond. it will release more energy. That's why the hydration energy will be higher. So as we go down the group, the hydration energy decreases because the size of the positive ion increases. So what is the expression for Kp? And Kp is for gases, like pressure exerted by the gas. So Kc or Kp is a product divided by reactant. But we only take a gaseous product here. So C will be the right answer because C is the only product which is gas and there is no reactor. Even silver is solid, silver oxide is solid, so we don't include that in the calculation because that is for partial pressure and that is exerted by the gases only. Dissociation of methanoic acid in aqueous solution is endothermic. When a sample of methanoic acid is warmed, so methanoic acid CH3COH, HCOH dissociate into HCO plus H plus, and this reaction is endothermic. So if we increase in temperature, shift the equilibrium towards right hand side. So more hydrogen ions will be produced. And what is the relation between pH and hydrogen ion? pH is equals to minus log of hydrogen ion, and negative log here means they're inversely related. So if the amount of hydrogen ion in the solution increases, the pH will get lower. So what happened to the pH? The pH will decrease. Then which solution has the highest pH? Because first thing, it should be a strong base because strong base ionize completely. They will have more hydroxide ion and pH of a solution are directly proportional. So option C and D, as I mentioned, aqueous ammonia. Aqueous ammonia is a weak base. Weak base cannot have a high pH. It will have a low pH compared to, but it will be above 7, but not high, like it will be 11, 12. But sodium hydroxide, without calculation, we can tell because high concentration means more OH ions will be there. More OH ion means higher pH because the pH increases as the amount of hydroxide ion increases and pH decreases as the amount of hydrogen ion increases. So strong acids have more hydrogen ions, so smaller pH. Strong alkalis have more hydroxide ions, so it will have a more or higher pH. Is it clear, this question? Then an indicator with a pH 3.8 to 5.4 is suitable for titration. So 3.8 to 5.4. So you have to remember, like memorize the vertical portion for different types of reactions. So this is suitable because mostly in acidic 3.8 to 5.4. So it is for strong acid. This is valid for strong acid and weak base. So which one is a strong acid and weak base? Nitric acid is a strong acid and ammonia is a weak base. Ethanoic acid, it's a weak acid and strong base, so that won't be effective, suitable. Ethanoic acid and ammonia, weak acid, weak base, there's no vertical portion for them. And iodine thiosulfate, we cannot use these indicators. We use starch as an indicator. Is it clear? Question 12, the reaction between concentrated nitric acid and concentrated sulfuric acid. So acid, the definition of what is the definition of acid? Acid are proton donor. So H2, whenever we mix two acid, even that happened like two acids. Now both of them are not acting like an acid. One which is stronger or having a higher value of dissociation constant, that will behave like an acid. So H2SO4 is donating proton and HNO3 is accepting proton. So H2SO4 is an acid and HNO3 is a base. So the question is, which statement is correct about this, like equilibrium? The Bronsted acid in the equilibrium. So as H2SO4 is an acid, as we know. So option with H2SO4 will be the right. Either way will be answer, or D. But HNO3 is not an acid, it is accepting proton, so that's why D is the right answer. And you can check for a reversible reaction. For a reversible reaction, H2NO3 react with HSO4, so it will donate. So reversible reaction, HNO3, H2NO3 is donating, that's why it is an acid. As a definition of acid, acids are proton donors. In question 13, when one optical isomer 2-bromobutane react with sodium hydroxide SN2 mechanism, which of the following is correct? So SN2 mechanism means bond breaking and bond forming will take place at the same time. So we have 2-bromo butane is there, so this will be C2H5. The OH attacking nucleophile attack, so try to form a bond, bromine will try to break the bond. And you can see there is a chiral carbon here. Even in the product there will be a chiral carbon, because the carbon attached with the 4 different groups. And if chiral carbon is there, it means that will be optically active. So there are two steps in the reaction. That is wrong. Here one step like bond breaking and bond forming take place at the same time. Butane 2-ol which form is optically active, that is true, because there is a chiral carbon present when bromine will leave and OH will be attached. Also chiral carbon is there. A racemic mixture is formed. Here only one position the OH can attack, so it does not form a racemic mixture. Like if a racemic mixture is formed in SN1 reactions, when first the bond break and then the attacking nucleophile can attack from any side. And the planar intermediate is formed. This is not a planar intermediate, like not trigonal planar, as there are 5 bonds are formed. So that's also wrong. In question 14, ethanamide is formed in one-step reaction. So which reaction will form ethanamide in one step? Look, if ethanoic acid is reacting with ammonia, so it will acid react with base, so it will form salt. It will not form amide. When ethanyl chloride is there, ethanyl chloride is C double bonded with O and Cl. And ammonia is NH3, in which NH2 is there, NH. So this is partial negative, partial positive, partial negative, positive. So NH2 will take position of Cl. So this will result in a formation of CH3, C double bonded with O and NH2. So amide is formed, plus misty fumes, HCl will also be there. So ethynyl chloride plus ammonia mixture. Ethanol with hydrogen cyanide, that is the formation of, like it increases the number of the carbon. And methanol, alcohol with methylamine. So same idea is that it will form amines, but it does not release. It will not form amide. Amine will be there, but not amide. The ester can be made by reacting. So how this ester is formed? This is C, C and C, and here this is C, 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 C and C. Ester is formed when alcohol react with carboxylic acid. So if I remove this part, like this whole part if I remove, so 1, 2, 3, so 3 carbon means propanoic acid. And this is coming from OH. So 1, 2, 3, 4. So second position we have a branch and OH is also attached. So One, two, three, four. So second position OH is there, and third position there's a branch. So it is 3 methyl. Third position there's a branch. So 3 methyl and 4 carbon atoms. So butane. And second position we have alcohol. So 2 all. So 3 methyl butane 2 all and propanoic acid. So propanoic acid and 3 methyl butane 2 all. D will be the right answer. So use page 5 and 6 to work out what is the compound. So we have to identify the bonds, the region from the spectrum. Page 5. This one is page 5. Yeah. So using page 5, what this refers to, this is about very sharp peak is there 1000, 100, 200, 3, 4, 5, 6, 7. So 1700 to 1800. A sharp peak is there, and there's a broad peak from 2006, 7, 8, 9. Yeah, 2006 to 3000. So sharp peak 1740. So 1740. Yeah, so this is, so either it will be an aldehyde, because you can see an aldehyde or a ketone. They have very, but ketone is having a peak from 1700 to 1680. So before 1700. But this peak, as you can see in the question, this peak is after 1700, so it means it should be an aldehyde. So there are, the only compound which is an aldehyde is A, so that's why A is the right answer. So this was Unit 4 from June 2017.